again, or hello for the first time. If you haven't watched one of these yet, and you're jumping deep into the series. I don't know what number this is, it's like 80 something, right? We're going for a while. But yeah, well, either way, welcome to one of my coding sessions with the language Bangalang we're making. The low-level explicit procedural compiled language that has the motivation for it, or one of the motivations was that the code should be able to move between CPU and GPU quite easily. Yeah, so let's get stuck into it. So in the last session, we improved the linking, so I think we can cut this out. And I also realized that we removed a call to this, and if I look at the usages, yeah, it says there's no usages, so I can clean that up. Another thing that I've found, because I haven't worked on this project much recently, I'm kind of getting back into it, is this isMember that I forgot we had, this utility. So back here, here it is. This is where we do that linking stuff, and I just kind of like done this hacky way of figuring out if link is a member or not. So I think we can do better than that. We can just do isMember, and we want it to not be a member, right? And then we can cut that stuff out. And we don't need to import type checking. One other thing I remembered is that I mentioned it at the time that this also shouldn't be a member. I looked at it a bit more closely, and that's not necessarily the case. Like here, we're calling syscall. This is part of the standard library. It's calling syscall directly, but it is a member in this case. It's a member of the Linux module that we import. So it's not that syscall should not be a member, but we need a way to differentiate it, because there could be other members potentially called syscall, and I don't want to prevent that from being the case, because that wouldn't be very intuitive if you just randomly couldn't do that. So another thing that I noticed, if we go to the definition of syscall, we look in the Bang code. Where is the definition? Here it is. Then at the end here, we have this @none. So it uses the none allocator, which is kind of a special allocator, which basically tells the compiler, like, don't generate anything for this. And that's because generally the reason to use none, I don't think there are many usages of none. Yeah, they're all for these special things, which I don't actually want to generate assembly for. So if we have something called syscall and it has the none allocator, I think that's good enough. So we have this thing here which tests whether the current thing is extern. We should be able to just go like this to determine if it's none. And so then I might have like is syscall, so the name needs to be syscall, and it needs to be the none allocator. So here we're saying if it's not syscall, this is not syscall. It might be easier just to search for syscall. I think there's quite a few places where I reference it. So that's is syscall. This is, so it's using different registers because syscalls have a different calling convention to other procedures. So definitely we need to make sure that that is using the correct condition as well. Down here is syscall and is syscall, like so. So they should all work still. Looks good. Cool, so that was just a little bit of cleanup from last time. And I think we can remove this as well. So this was where I was worried about that syscall stuff, but we just cleaned that up. So that's looking good. And now actually the next thing, I want to do a bit more cleanup stuff. well, this is not really cleanup, I guess, but this is, these two here, these are kind of features that I want to add to the compiler for outputting, kind of like, you could think of it as like debug information. So it'll help us during development of the compiler. Like I want to print out the GLSL that gets generated, or print out the AST structure. I'd like to be able to do that just for an arbitrary portion of the code. So if I have a little portion of the code and I just want to make sure that the AST looks right, because sometimes it's hard in the debugger to analyze the AST very well. If we could print it out in sort of a, I just want to print it out in like a JSON format. I think that would make it much easier. And I'll also make it so that you can print out the whole program as AST. Could potentially be useful, and it won't be hard to do. So let's start with the GLSL, I think. I think the first thing, I can probably close these, is that we want to go into the main and update these, our build command. I did actually kind of have the idea that I would like to change a little bit. I mean, the Bangalang, saying that it's a compiler for Bangalang is kind of like, I don't know, I feel like it's a bit redundant. If you're calling it, you should know that. So I'm just going to simplify that a little bit. This I'm going to put up here. So I do want the description of what goes on here, because here we have like a list of commands and we don't actually describe what the commands do here. We just say use the help command for that, use the help flag for that command to get more details. So that's why I do want to have a summary here. This is for the build command. I guess I should do the same, reformat this for the run command. Like so. So input. Now I want to add an extra, my idea is that I want to add an extra flag called target. And currently I would say that our target is x86-64. That's what we're compiling to. And I'm going to make that the default for now. I mean, ideally, the default would be the platform that you're running on. But then we don't support ARM. I mean, the other one would be ARM, basically. The other platform that you would be running the compiler on would be ARM. Yeah, and that would be it. So if there is another argument, I'm just going to assume that this has to be like directly after input. It would be nice if ordering of these things on the command line didn't matter, but it's not such a big deal. It's fine. So this comes after the input. And I also want to, I just want to get this raw bit here. So I want to strip this bit off. And since we're making it order dependent, it's like kind of unnecessary, but once we get into a better CLI, then this should mean something. And I'd kind of like to put it there because it makes more sense to me. Anyway, so what I want to say is that if target has this prefix, then target equals, we're just going to strip the prefix off. So we're going to slice it to take whatever's after target. And then we're going to have else if, because there's another way to do it. I want to be able to support that you can have a shorthand, which is just -t. And again, I want to strip that off. So now we should have the target, which is just this. Great. We want to check whether they are valid targets, kind of like we do here with the commands. So I'm going to put this here and say is valid target, targets. So we need to specify what the targets are. So we have x86-64, whoops, as we mentioned before. And our new one, I'm going to call it kernels. So any kernels that get generated as part of the program, they will be output in their own file. That's the idea of this target. So right now, the only kernels that we, well, I mean, when I say kernel, actually, I'm only really going to support GPU kernels, or like, I mean, if they're just running as normal CPU code, then there's not really much value to doing this. It's more for like generated code, kernels that are generated code. So not Bangalang code, but some other generated language, like GLSL in this case. Okay, enough explaining. So now we know it's a valid target. So if it's not a valid target, we want to go in here. And so now there's two cases that could be an error. So if it's not if we're not looking at a help flag, that means that we're looking at an invalid target or an empty input, which are both error states. Like so. So here we want to say, how do we do it here? Here we go. So let's say target is required to be one of, and then put the target, it's going to have to be a formatted line. So that should get our error message if we don't supply a target that is valid. I want to add on to here options, and we should probably say that you can supply options here, but the only option that we support right now is target or -t. And that's the target to compile to. And we have some phrasing that we use, possible values include. So let's put that here. Where was it? Like so. So that's going to have to be a formatted line. And again, we'll put the targets in. So I think that means that our CLI now can handle targets. Let's try. I was playing around before, so I think, whoops, let's make this bigger and we clear it. So I think Odin should just run. Nope, okay. But I think we can do like export. Oh my God. I just want nothing. Okay. And I wanted to search for export. Failed. I don't have any commands in here that export. Okay, whatever. I hope you guys don't hear that. I can hear like all this boo, 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 boo when I'm trying to do something that's failed, but hopefully it doesn't do that for you. So path equals path /home/ CLion /downloads. Oh, do I have to really do this manually? Because it's like this big stupid name. So I think it's like that, and then if I echo path, I think that's right. So if we go Odin, yeah, now it works. Okay, so now that we have that, we can go Odin run source, so that will run the compiler, and then we can go dash dash and specify our compiler options. So we want to do a build, and we get our usage. Okay, this is, and we get our error, you know, input is required, and then it gives our usage. And so we say, okay, I want to build OpenGL. Because the playground doesn't have kernels, so in this case we use OpenGL. And I want to say target equals F. So we should get target is required to be one of. Target equals kernels. Failed to read entry module. Oh, because I spelled it wrong. Library core not found. Ah, that's because it's creating this binary, and I actually want the binary to be here. I don't think we need bang, but I want the binary to be here. Because I think I made all these configurations. In these configurations, we can set the output path. So I wanted it to be bang C, bang C, bang C, in bin. So I'm going to do the same thing in here. So I think we go out equals bin slash bang C. There we go. Okay, so it ran properly, it built, but we're not actually doing anything with this target flag, or this target option right now. Make a bit more space. So when we come down to the actual build call, we need to pass the target in. And build needs to accept a target, which we're going to default to x86-64, because there's a couple other places that build is called, like here, and we just want to use x86-64 for those. So what does build do? It does a compile, and then it does all this here, which is assembling and linking. So assembling and linking is not going to be required when we do this new target, this kernel's target. It's just the compile we need to do. But the compile is going to be a little bit different. Or is it? I think we can just do that. I mean, we're passing the NASM path in, which doesn't make sense. You know, we don't want assembly out. But for now, we could just do this, because then we can just say, like, if target equals x86-64, then do all this assembling and linking. Otherwise, there's nothing to do. We don't need to do it. Yeah, I think that should be fine. And I think we're going to ignore this assembly path, because we want to create a file for each kernel, right? So we're going to create our own file paths anyway. We're going to just ignore this one. Okay. Why is that not happy? Probably just because this is not being called properly. So now that should be happy. So then this variable should be happy. Okay, everyone's happy. So now when we do the actual compilation, everything in the beginning should be the same. You know, we load the source files, we tokenize, we parse, we do type checking. There's type checking. Generation is where we split off and do something different. Because here we do an x86-64 generation. We don't want to do that anymore. We also don't really need this string builder and this file stuff. So I might, about here, do a switch on the target. x86, whoops, 64, and we'll put in a default case. Which we should never get to, just as a sanity check. Okay, so then all of this stuff is the x86-64 stuff. Okay, and for kernels, it's going to be much simpler. It's just going to be a call like this, but we're going to go to the kernels package. Another thing I'm noticing in here is that we should destroy our builder. We should be a bit better about that sort of stuff. There's a lot of places where we just don't clean up our memory, and we should do that. So add that there. It seems like we do, I think we do need the context. Let's put the context back up there. Okay, so now we need to create this. I think basically that's it. So in generation, let's make a new directory, kernels, and I'm just going to copy the program generation from x86-64. Should be kind of the same, but much simplified. So let's call that kernels, and then there's a whole bunch of printing of assembly, hard-coded assembly that we want to get rid of. This data section is more assembly. Static vars we don't care about. So let's cut out the static vars. What else can we get rid of? Generate. We don't need to generate main statements. We're only generating procedures. So let's get rid of this main statement stuff. So we're cutting it right down. And then in here, so the code allocator, this is just for like regular procedures, which we don't care about. We only care about kernels, so we don't actually need to generate that. Which I think means we don't need this at all. I don't know why there's brackets there actually. I don't think there needs to be. Maybe I'll also fix that here. Does that need brackets? Yeah, I don't know why that would have needed brackets. Same with that. There we go. So all that does is recurse now, basically. Because we might have a procedure that calls a procedure that calls a procedure that then calls a kernel. So we just need the recursion to happen. And now for the compute shader, we'll take the brackets off here as well. And this is generating the static variable, which would then have been added to the data section in assembly, but we don't need that. So now we're left with, we generate the GLSL program. And just like in main, well, let's import kernels here. Just like in main for x86, we did this file stuff to make the output file. Let's put that here, do the same sort of thing. And also the builder init, let's have a builder destroy for that. Actually, we probably want that here as well, right? Yeah. Okay. So it looks like we need OS imported. It's the procedure context. procedure context. So now we want a new path. We kind of want the output path, and then I think the file name, I'll make it the qualified name of the procedure, or the kernel in this case. Just as a reminder, in case everyone's thinking like, what the hell do you mean by kernel? In our OpenGL example, we have this, which is considered a kernel. It's just a little procedure that has a specific signature, and we can pass it to boomstick.bang. And this is the thing where, like, right now this is going to run on the CPU, but if I say at gl.compute shader, now it'll compile this kernel as an OpenGL compute shader, and when we do this, it'll run it on the GPU. That's kind of the secret sauce in my language. So I think in main, we don't have, or like bin. Yeah, so when we do a build, normally the output file is bin/something. I think we want to change that to be bin/something else. And actually, it's good that we changed this to a compute shader, because that's now this program will output a compute shader, which means that this will have something to generate. Before, when it was like this, it was just, this is just a regular CPU procedure, so it's not, there's nothing to generate. So for here, I said, I think we have it up here. Yeah, the qualified name. I believe this is the qualified name of the procedure. We'll find out. And I'm just going to put GLSL extension on it. I think that's it. Like if we run that, it runs fine. And we get this file, which is an OpenGL compute shader. And it looks pretty good. The only nitpick I have is that it should have, that should be indented. I've got another note to fix indenting, because I also want to improve the assembly indenting, so I'm going to do that all at once, I think. But apart from that, it looks great. For generated code, you know, it looks, I think it looks pretty nice. Cool. So now we can use this command line, you know, if we're having issues, if we're working on the compiler, doing some more advanced stuff in GLSL kernels, and it crashes, and we're like, what the hell's going on? Then we can do this, and we can examine the GLSL code, and we can be like, oh, okay, yeah, there was an F there for some reason. Let's try and fix that, you know, something like that. Cool. Okay. So we can get rid of this guy. Now this one, I think it's going to be a little more complicated. Let's see how we go. So this is going to output a JSON file. So first things first, I guess, back in our main, we need another target called JSON. And I guess if we search for kernels, then we find the only place where we need to do something to JSON. So we JSON like that. So in this case, we want to do all the file stuff. And that's the common case, right? Kernels is kind of the special case here. So, but it's kind of a little bit difficult to sort of like make this, kind of like make this and this optional. Or maybe not. Maybe we can just go up here and we can say, you know, if target is not kernels. Then we need to, well, this is probably going to defer to the end of the scope now. It's probably going to happen immediately. You know what, I'm just going to make this always happen because there's not really much harm in it. If it doesn't get used, it's not a big deal. We're just going to make the file output stuff only happen. So if it's not kernels, sorry. If it's not kernels, then let's generate an output file. Because the common case is we want to output something, right? So right now, the file is the NASM path, which is kind of specific wording. Let's call it the out path. Because NASM path assumes that we're building to assembly, and that's not really the case. So when we call compile up here, so now we have this .asm thing. I think I'm going to do a switch here. We're not going to end up duplicating that much. Not much at all. So here, we could do our assert, like so. We got kernels, x86 64. So all of this stuff will go into the x86 64 branch. But we don't need this if wrapping it anymore because, whoops, we've already established that we're doing x86 64. So the difference now is that for kernels, we just put the out path. We don't care about the output either. And for JSON, maybe I'll put that there, put them with, you know, the thing that needs them. For here, we're going to make a JSON file. So the out path is, well, I guess we need to make that JSON path. Okay. All right. Great. I think that's good. So now we will go into compile with the JSON file name, which we then pass on to, no, we don't pass it on. We just know to write to that file. So now we need to make the JSON generate program. Which I think is going to be also very simplified. If we go generation, JSON. So let's copy this guy again and see what we want to take from him. JSON, get rid of kernels, get rid of that. So again, obviously we don't care about this hard-coded stuff. We don't care about this. And we don't care about the static vars. What do we care about? I mean, I think it's basically So here we're kind of like splitting it out so the procedures are done differently. But the AST, even though we have like all these references to specific procedures and stuff, the AST is really just a list of top level statements, and each of those is an AST node, which we can then just do recursively. So I don't think we need this procedures business. That chops out a big chunk of it. I think we just need to do this. And for each statement, for statement in, we're essentially going to do like I'm going to make a procedure that will print a node, and statement is a node. I pretty much always pass these things as pointers. Is print the right terminology? Because we actually want to print it to the context dot output, right? So I don't know if print is the right terminology, but that's fine. That's fine. So then when we go to AST utils, so we have like make node, clone node. So let's have print node. It doesn't actually output anything. I'm going to call this root. Oh, that one doesn't take a pointer, but that's kind of a special convenience. It does a new node. And we need to pass in our string border, which is our output. So we need strings. Okay. So I think now basically there needs to be a pointer. Ah, this is already a pointer. That's right. I changed it, so that's already a pointer. So now basically it's just like, how do we print the JSON for a node? So let's do SB print line output. I guess the first thing we need to do is put this curly brace. It's an object. Last thing is to put a closing one. We'll improve the indenting later, but let's just do some simple indenting now. So what does a node comprised of? It's a type. I think basically everything is kind of optional. I'm not going to put I don't think I'll print I won't print this for now. It might actually be useful to have that as well. Maybe I shouldn't exclude that. I just feel like it's going to make the thing a lot noisier. Maybe there'll be an option to include that. So let's just do this for now. I think basically everything is optional, like it might be there, it might not be, except for type. There's always a type. So let's go, need to double quote it. Type %s root dot type. And then if root dot value is not an empty string, this is a formatted line. Then we want to add a line which is value equals value. Does it need, I think that needs quotes around it too. I don't think that would have. Can I do? Okay. Maybe I just do it like this. Okay, so if value is not empty, then we add the value. What's the next thing? Data type. So if data type is not null, so this is where we need to recurse. Well, I guess we say data type, like so. And then we say print node root.datatype. Now the indenting is going to be really terrible to start with, but we'll fix that up in a minute. What's our next thing is the allocator. So that's basically the same. If there is an allocator, then we recursively print that. Next is a directive, which is a string. So maybe actually I'll copy this guy. Directive, like so. What's next? Children. So for the children, we're going to have to loop through them. And I guess if it's length of the children is greater than 0, so if we have children, then we print children there. We're going to need to print like an opening array and a closing array. And then we're going to have a loop. So for child in root.children, print node child, like that. I'm pretty sure there's going to be lots of issues with this, but let's see. It all compiles, I guess. So let's target JSON, see what happens. Undeclared name JSON and main. Yeah, that's right. So we need to import JSON here. Try that again. Okay. So if we go to bin, will it be in examples? Oh, yeah, there we go. OpenGL.json. So this looks like a mess. Couple of things right off the bat that I notice. We're not adding commas. We need to add commas between the properties. And we also need to make this like either one big array, or maybe we need to have like an encapsulating object. Also, this needs to be quoted. Okay. So let's start with the encapsulating object. Maybe we'll just manually do that. Yeah, let's just do it manually. So in the program, context.output, we want to do that. We want to have closing. Oh, maybe we need to put the ampersand like so, and we want to have some children, basically. Children, and I guess we'll give it a type. Oh, so this needs to be quoted. So give it a type, and here we know there's a comma after it, so we'll just put a comma. And I'm just gonna make up a program. There is no node type called program, but I'm just gonna make it up and put it here. Maybe we'll put this up here, and then we'll put this. Well, really, we can just put it all there, right? It goes between the brackets. That's the general idea. Okay, so that should be a big encapsulating object. So then we don't just have, like this, a lot of opening, closing braces like that. Now in here, we want to do the commas. So I think, like, we only want to put a comma if there is another thing coming after it. So I think actually what I'm going to do is like take off the new line. And say, I kind of want to say if we've already added something, then we need to add a new line. Maybe make this a bit more explicit, like this. We're adding a new line, printing a new line. So this is always going to be the case because we know we have type first. But here, oh no, we always have type first, so all of these is going to come after something. So we can always just put this here. Just print a new line before each of them, but then we need to be careful that we don't, like, we don't put a new line here, we don't put a new line here. Print node itself. Maybe print node itself should not put a new line. I think it's safe to put a new line after this last. No, we won't do that. Instead, we will have like this, because we don't know if this is the last thing. This might be the last thing. And we don't want to put a new line after that. And these nodes don't print new lines. I think that should... Sorry, it's not just a new line. It's comma new line. We want to add the comma and a new line. So maybe we can just do this. Like, we just want a comma. Like so, and... But after the last thing, we don't want a comma. We just want a new line. Okay. So I think that's good. I think that's hopefully solves most of our problems. This is now quoted. We have a big wrapping thing. We have commas. The other thing that really makes this hard to read is the indenting. So let's say indentations you have to specify, and oh, wait a minute, this is totally the wrong place. Print node, you have to specify the indentations. And before every line that we print, we're going to print indentations. Like so. Before that, before this, before this, before this, before this, and this, and this, and this. And then within the nodes, we also need to figure out how many indentations. So I'm just going to, let's put it here for now. Print indentations. So that's going to be similar to this, but we don't need the root. Like so. And it's just going to be, I'm just going to do a really simple indentation here, which is like we just print space, space, for can I do it like that? I think you have to do it for index in 0 to that. Yeah, that's what I'm trying to say. So it should do it indentation times. Add a couple of spaces. And now just need to say like, I think it's just like indentations +1 so that it's in line with this. Same with the allocator. The children, however, we don't want it to be in line with this bracket. We want it to be one further. So I think it's +2. Let's see what happens. We crash. Because we need in the program to specify the indentations. Which will be 2, I think. Because this is already indented once. So the second indentation will be a little bit deeper. Let's try that. We need to actually run it like this to get the JSON. Let's have a look. Okay, looking much better already. There's a lot of red on the right, so there's obviously some issues. I just don't know what they are yet, because why is it all red? Because this looks good. Okay, when we have multiple children, we need to do comma new line between them. Okay. So it's looping through the children. So I think we just put like index here and f index is greater than 0. We need to put a comma. Comma new line. I think that's it. Is that it? Oh, I keep running it from there. How is that? Okay, still a bunch of errors, but at least not, the whole thing is not an error. That doesn't look quite right. So after the last child, we still need to do a new line before the closing bracket. After the last child, we'd do a new line before the closing bracket. Okay, let's try that. Every time. Okay, I don't see any red now. Is that it? He says with surprise. Like, did that actually work? I guess so. I mean, it looks, I'm surprised that didn't throw an error. We have like double quoting here. String literal. So string literals have the quotes already. So I think that's kind of a special case where the value, so if it's a string literal, we're going to do something special, which is to say we're not going to put quotes. No, don't run there. I know how tempting it is. Okay, now that string literal looks good. Okay, let's take this and go to a JSON formatter. Parse error on line 105. There are a lot of lines. There's a scroll. Here we go. _0 and 105. Okay, so we didn't get a common new line. I think this is because it's probably better if we didn't do this, but we have this special code here for the top level. So for between these children, here it is. This is our loop. I was going to say if index is greater than 0, but this loop is going to happen multiple times for each main module, so we might need to have like a generated node or statement. I've been doing too much TypeScript lately. There we go. Just to say whether it's generated a statement yet or not. So in the beginning, that's false. Generated statement. Now, after we recurse and we come out, that means that we have. So we say true, which is not valid because it's a parameter. So in Odin, the way to get around it is this weird syntax, which I guess creates a local variable with the same name that you can then modify. I guess that's the idea. So we set it to true after that, or after doing an individual node. We also set it to true. And here we say if we have, then we want to print comma new line. Okay. Let's try that. And I got caught by that trap again. It's a big file. So if I go to 105 now, see, that looks more legit. I thought there might be something right at the end too. So after the last one and before this, I think we just want a new line. Oh God, every single time. I'm not learning. Okay, cool. So let's take that, put that in there, validate, format. It seems happy with it. Okay, awesome. So we have JSON output of an entire program. This is the AST for an entire program, so you could do with that what you will. The thing that could also be handy for me later on when I'm troubleshooting is just to call this print node for the area that's I suspect is not quite right, and it should print out the AST, and then hopefully I could get a bit more context about what's going wrong. Cool, pretty happy with that. We're just about at an hour. We can cut that out. I don't think I have anything that's really like very tiny to do now. I should probably prepare a few things, like just can look at a few of these and see what might be a small thing to do, have a think about how to do them. So then when we get to the situation where we have like a little bit of time, then I could probably bust out some of these. But to do it just off the bat feels a bit risky. I might just go down a hole or something like that. So I think we're going to call it the end of the session. Pretty happy. We did a little bit of cleanup from the last session, which also included taking care of this, which is nice. And then we printed the GLSL and the ASC. I think that's pretty good. So we knocked out 3 things, and we also cleaned that up a little bit. Yeah, 3 points. Nice. Okay. So thanks for stopping by. Have a good one. Ciao for now.